Hello, I am Dr. M. Fatima from SATA Institute of Research and Technology. I am taking active filters. In last lecture, we have already seen low pass filter, first order low pass filter. Now moving to the second order low pass filter. Second order low pass filter, in the second order low pass filter, the frequency, the cutoff frequency becomes equal to 1 by 2 pi under root of R3, R4 and C1, C2. As we can see here, R3, R4, these are the resistors, and C1 and C2, these are the capacitors. So here two capacitors and two resistors, that is two combination of resistor RC network is used. That's why the order is 2 here, and this R2 and R1, this is showing the uh, feedback network which is connected to the negative terminal. Uh, as we have already seen in first order system, first order low pass filter, in that filter the slope of the uh, attenuating signal or slope of the fall of signals is minus 20 dB per decade. But here in the second order low pass filter, the decade will be changed. The decade becomes minus 40 dB per decade. So see here, this is the circuit diagram. This one is the circuit diagram of the first order low pass filter where this RC network was used. And this is the frequency response. Here the slope is minus 20 dB per decade. But if the second order filter is used, then second order filter will give the slope of minus 40 dB per decade. This diagram is showing the filter response. These red lines are showing the ideal response of the low pass filter. That is, the low frequencies are passing and high frequencies are attenuating. And these green lines are showing the practical value, practical response of the filter. Here you can see some variation or oscillations are present in pass band and stop band of this filter. So in Butterworth filter, the ripples are present in pass band and stop band. These oscillations are called ripples, and these are present in pass band and stop band of the Butterworth filter. This diagram is showing the discrete value of this low pass filter. This is the discrete response. This is continuous time response, and this is discrete time response of the low pass filter. Now this diagram is showing the frequency response for the first order and second order low pass filter. This the slope. See here, this red color slope is showing the slope for the first order low pass filter, and the slope value is minus 20 dB per decade. And this blue line is showing the slope of the second order low pass filter. Here the slope value is minus 40 dB per decade. So you can see here the higher order filter is having steeper cutoff, steeper slope. So what is the requirement from the filter? The value after the cutoff frequency, the slope must be very steep. But practically, this is steep. The immediately zero value, immediate zero, or the immediate attenuation is not possible in filters. The slowly the signals are going to attenuate, but with the increase in the order of the filter, this slope is going to increase. For the third order filter, the slope becomes minus 60 dB per decade, and so on. For first order, the slope is minus 20 dB. For the second order, slope is minus 40 dB, and for the third order, slope will be minus 60 dB per decade. So with the increase in order of the filter, the steeper will be the slope of the filter, which we required from the filter. Thank you. This completes this lecture.